Welcome to a lesson with Dr. Powell. Let's take a look at how we can use a short spectral sequence argument to show that if we have a short exact sequence of complexes, that we actually get a long exact sequence of homology. So let's turn the short exact sequence vertically like this. All right. If we start our spectral sequence with vertical arrows going downward and take homology, we're just getting a bunch of zeros because we're assuming short exactness. So if we get lots of zeros, it means in the total complex at each location, homology is just going to be 0. Okay. All right. So let's see how we can use that as we move along. Okay. So if we now turn so that we start with horizontal arrows. So the first page will get something looking like this. So we take horizontal homology and we have vertical arrows between them. All right, that's a good start. Now, if we go to the next page, so we take vertical homology, then at this point, we're going to get the co-kernel of, so suppose this map's named alpha, I'm going to get the co-kernel of alpha because this is the kernel divided by the image. It's just that. So, and then over here, similarly, we get the kernel of this map beta right here, say. And notice that as we go to more pages, we're just going to have zeros between these guys and these guys. We're not, as we move along. So we end up getting that. Yeah, so after this step, we're going to get stabilizing. So what's going to happen when it stabilizes? It's going to be the same thing forevermore. And we already know that everything will stabilize eventually to 0, since homology is 0. We're looking at quotients and subobjects of 0, a filtration of 0. So it's just going to be 0. So that means when we take homology after this step, we're just going to have 0. Well, what does that mean? That means that so the homology of what we have right here is 0, which basically means that this is an isomorphism right now. So this is an isomorphism right here at this step. Let's use that fact. So so this arrow is actually a double arrow and it's an isomorphism. All right, so how can we use that? So let's kind of write this out. We have Hn of A maps to Hn of B, which maps to Hn of C, which, let's see, well, surjects onto the co-kernel of alpha, which is actually isomorphic to the kernel of beta, which injects into, well, precisely, let's just draw the arrow right here. So kind of what we get is that the image of this map is the kernel of that map. So we get exactness as we move along. If we just extend this map like this. So we kind of map going from here to here. So kind of here, get exactness. So we just kind of continue that, get a long exact sequence of homology from a short exact sequence based off of this quick little spectral sequence argument. Thanks for watching.